Okay, we're here at the top of page 2 for 2.6, and I'm just trying to make sure I can get everything focused here. Okay, there. Sorry about that. I'm having to adjust it for you. I want to get it good and solid. Okay, so let's look at what this means. When we say it's just the same as solving with an equal sign, but with one exception. Okay, so it says solve each inequality, graph the solution set on the number line. Very important that you add that piece in. Okay, don't just solve it, but also graph it. When we get to the test for chapter 2/chapter 3, our next primary exam, sometimes the answer will be just in the inequality with a greater than or less than, greater than or equal to, less than or equal to sign. Sometimes the solution will be as a number line, and sometimes the solution will be as a interval notation, so you need to be ready. And so in fact you'll see me do all three with interval notation. For our examples here in our notes, because sometimes they ask for that in the book too. So we're going to practice all three. So our goal and our steps stay exactly the same as the beginning of 2.1, 2.2, 2.3. So all this is the same as 2.1, 2.2, 2.3, all that we talked about. So our goal is to get x all by itself. Isolate the variable. First, we need to make sure it's rearranged in a solvable form. So we look to see if there's any simplifying we need to do. We check if there's parentheses, and that may mean we have to distribute or simply multiply, or just notice that we have a negative number involved. So we need to remove any parentheses. Then we need to combine like terms. So we check for both of those things. Most of the time, those won't even be there. Okay? If there's fractions at this point, you can go ahead after you've looked at removing parentheses, or maybe even before, depends on what your level of comfort is. If there's fractions involved, you can also eliminate the fractions by multiplying by the least common denominator. You'll want to pick a side, and you get to pick which side, left or right, and then you do that by using the opposite operation in front of the term that you want to move. So if you want to move it from the left side to the right side, you look at the sign in front of the term that's on the left side, and you do the opposite of that. And if you don't see anything in front of it, assume it's a positive. Okay? So in that, the two steps we're trying to rearrange. This is all the same as we've done before. Then we ask ourselves, what's happening to the variable, or in this case we'll just use x. So what's happening to x, and then we list that in order, and then we reverse the order of that. Okay, so you can list it as, you can write that as a list, I should say, or you can draw it as a timeline. Or for some of you, you might be at the point where you can just kind of think in your head what's happening, and then you can get to where you're comfortable undoing it. And the undo reverses the order of that list and use opposite operations to undo everything that's been happening to the variable. You undo it by doing it in reverse order. Whatever happened last, you undo that part first. Use opposite operations the whole time, and whatever you do to one side, you do to the other. Okay, so both sides, it's key on that. And here's where the one exception comes in for inequalities as opposed to equals, just equations. Okay, if you multiply or divide both sides, so at any point in the undo process where you do something to both sides of the inequality, if you multiply or divide both sides by a negative value, you continue with that. The negative's fine, nothing different than we've done before. You do your positives and negatives just like you've done before, but you flip the inequality. Okay, and then of course you check your answer back in the original equation. So step 3 and 4 are really your solving, and then you have your check. See if what you've come up with as the answer really does make the original statement true. Okay. Let's try number 30 here. Now, for the purposes of getting used to this exception, I'm going to go ahead and create the situation where we have to deal with it. You could actually solve this one without having to deal with it, but I want to get you the exposure and the practice as soon as possible. So let's go through our checklist. Are there any parentheses that need to be removed on either side of the inequality? And some of you may want to visualize this as an equal sign. Okay, this is where the equal sign used to be. So it's a less than now instead of an equal sign. Okay, so that's all that's different here. This is where we're balancing it. This side weighs less than this side. This side has a lesser value than this side. Okay, we want to find the value of x that makes that statement true. So we treat it like a equation. We look for parentheses. There's not. That's taken care of. We look for like terms on both sides of the inequality this time. 2x and 11 cannot be combined. 3x minus 8 cannot be combined. So now we look to see if x has picked a side, and it has not. We've got 3 on the left, 2 on the right. And I'm going to force the issue here and make us deal with this exception so we get the exposure and practice. So I'm going to choose to move the variable to the right side. So I look in front of the one that I want to move. It's a blank, so it's really a positive. I do the opposite operation, which is a minus. So I'm subtracting 3x from both sides. And I'm left with a negative 8 is less than 2 minus 3 is a negative 1x, or just negative x, plus 11. Okay, I've got x on one side. I start by asking myself what's happening to the variable here, and the first thing that's happening is it's getting multiplied by a negative 1. The second thing that's happening to x is that 11 is being added, so you would add 11. If I had to put a value in for x, the first thing that would happen is it would get multiplied by the negative 1. If you need to, write it that in as a negative 1 so you can really see it. Then 11 would be added to it. If you were going to do that as a timeline, it would look more like this. Here's your x, and as we read left to right, it would be multiplied by a negative 1, and then 11 would be added to it. Either one of these, or in your head, find your comfort level. Find what makes the most sense to you. Now we undo that process. This is like the doctor's prescription to help us see step by step what we have to do. No question, no wondering what we're moving or what does the opposite or whether we add or subtract. No question. We just follow a reverse opposite list here. So we reverse the order. Step 2 becomes the first step. Step 1 becomes the second. Or we would go right to left on the timeline. We'd run into the plus 11 first, make that opposite, subtract 11, just like the add will become subtract up here. Then we'd run into the timesing, the negative 1, that would become dividing the negative 1. Notice the signs stay the same. It's the operation that's the opposite. Here, instead of multiplying by a negative 1, we're going to divide by a negative 1. It's the opposite operation. Okay, from there, this list tells you what to do. You can either follow the order of the reverse list, reading up the list here, so new step 1 followed by step 2, or you can go right to left across the visual timeline. It'll tell you exactly what to do. Either one says to start with subtracting 11 from both sides, so that's what we're going to do. Negative 8 minus 11 is a negative 19. The less than does not change. We did not multiply or divide. Okay, so you only flip the inequality if you multiply or divide by a negative. Okay, so I still have my negative 1x here, but the plus 11 minus 11, they cancel. That was the whole point. So we've taken care of that first step in our prescription. The second step tells us to divide both sides by negative 1. Hear yourself say that. Divide both sides by negative 1. There it is. I'm dividing by a negative 1. So here's my, you can even as you make this list, as soon as you see yourself writing multiply or divide by negative, that's your little exception. That's your little red flag. Well, blue. I'm holding a blue pen, but it's your little flag that goes, hey, hey, hey. Remember? So now as we divide both sides by negative 1, again to undo what's happening to x to get it all by itself to solve. This flips. It goes from a less than to a greater than. Okay, so we flip the inequality right there. And what we're left with is x is on the right. We've got that, now it's a greater than sign. And negative 19 over negative 1 is positive 19. So, and it may feel a little funky. What you're saying is that 19 is greater than all the solutions for x. okay, which is another way to say x is less than 19. So notice the x ended up on the right, so it's like you read it from right to left. X is less than, this answer here, x is less than 19, or another way to, or you can just switch those around, but the alligator continues to always point towards the number that it's hungry for. And the reason why it flipped here from less than to greater than in our original inequality is because we divided both sides by negative, which changed the sign of the number, moved it to the other side of the number line. The alligator followed that movement. Okay, so I ran out of space here, but let's, on a number line, what that would look like is here 0 is reference 19. It would be an open parentheses and then all values less than 19. And if you end up with x on the right and you are on the right side and you don't know what that means, like does that mean greater, is that x greater than 19 or excellent? Try some numbers. Draw it on the number line, and before you shade it in, go, okay, 0 for reference. Does 0 make this true? If I put 0 in for x, is 19 greater than 0? Yeah, that's a true statement. So if 0 is true, you shade the side that includes 0, and that'll help you see that, oh, this is a less than. It's all values less than 19. This means the same thing. X is less than 19. So in terms of a interval, negative infinity, comma 19, those are your two endpoints on the number line. And then we don't include 19. We also don't include negative infinity. It's a concept, not a value. Okay, it goes on forever. Okay, let's try number 36. I'm just going to double check my screen position here. Actually, I'm going to pause the video, readjust it just a little bit, and because this video went, it's long enough as is. Okay, so we'll go to the middle of the page for the next one.